diagnostics that we will do, we will look at, they will all come down to the linearity and normality conditions. That's most of the parts. So it is possible that the relationship is non-linear. If that happens, we need to find a way to do that. And for normality, for example, we can transform the data and attempt several ways in which we can make it linear. If the relationship is non-linear, we may have to fit it through, say, a log transformation of a linear relationship, and we go ahead. But after that, you realize that the normality will now change to a log normal instead of normal because we have transformed the data. But we don't always have to transform data. We may go around a non-parametric approach, or if you like, a semi-parametric approach of dealing with the normality and linearity. One of them is going through the quantile regression approach. What does that mean? It means that you are going to, let me use this side of the board. You are going to take your data. This is your center. So this side is 50%, and this side is 50%. Supposedly 50%, but both sides may not be equal because you're not sure if it's normally distributed. So what you would do is to avoid normality conditions and linearity conditions, you are going to break the data into different quantiles or equal divisions. And for each part of the division, you are going to fit one regression here. So let's say R1, R2, R3, all the way to Rn for all the divisions that you have made. And that solves the linearity and normality issue because they are, if you like, local. They become locally stationary and normally distributed, because the data here, if it's large enough, we know data for a typical regression equation of statistics, your data should be 30 or more. And because we are staying within that range, stationarity, let me not go into stationarity, just normality is fine. We are sure of having a normal distribution within that range of values, the same across. If you're able to do that, and we divide, say, 10 divisions, we are going to have 10 different regressions, but the division into quantiles is on the dependent variable. That's what is done. So you can fit look at the quantiles of the dependent variable and fit it across the independent variable for a simple linear regression or for a multiple linear regression. So that's the last part that we'll do. And this is very useful, especially in real life conditions or relationships. There's no normality assumed. So we need to be realistic in our practical use of quantitative decision tools.